Now we need to learn how to classify mixtures as heterogeneous or homogeneous. Mixtures are just a combination of two or more pure substances. So if we have salt and water, if we have air around us, which contains nitrogen and oxygen and some other components, all of these things are mixtures, and the key is that they are mixed together, they are not chemically bonded together. So if I look at the drawing on the left, this represents hydrogen and oxygen. This is a mixture. Notice that we have elements, and these are molecular elements because we have our green, green, red. They're two atoms connected together, but they're the same atom. But there are two different types of elements in this mixture. When I look on the right, this is actually a pure substance. Because while they both have hydrogen and oxygen combined in the same container, here we have the hydrogen and oxygens bonded together. And notice that each unit present here are all exactly the same, and these are actually representing water molecules. So these are just water molecules, so it's a pure substance. On the left we have hydrogen and oxygen representing a mixture. Based on the images below, select the true statement. Now that we know what a mixture is, we need to classify it as homogeneous or heterogeneous. Think about the prefix here. What does the prefix homo mean? It means the same, so a mixture that is homogeneous is the same throughout. What about hetero? Hetero means different, so we see different throughout. So when we're looking at mixtures, we have to find a way to determine whether it's homogeneous or heterogeneous. One way to think about this is to look at our mixture and imagine we were taking a sample from various points in the mixture. So for example, for our drink, if we took a sample from the bottom, the middle, and the top, would they look the same? The answer is yes. So if I took a sample from all three levels, they would be the same, and that's a good indicator that this is a homogeneous mixture. On the other side, if I have a heterogeneous mixture, I'm going to see differences in my samples. So say we took a sample over here by the bank, one here in the middle, and maybe one farther upstream. What we're going to notice is that these three samples all look very different from one another, and as a result, we would say that's a heterogeneous mixture. Even though they might all contain water and dirt, they're not exactly the same throughout, and we would start to see that the dirt and water would be start to separate from one another to a certain extent. So different is heterogeneous, same throughout is homogeneous. Can you identify this sample as heterogeneous or homogeneous? This is actually a heterogeneous sample. The yellow portion is actually sulfur. The shiny or metallic part are iron filings. Notice that if I look at this sample in different places, so here, here, and there, it does not look exactly the same. It has a different composition. Therefore, this is a heterogeneous sample. In order to be a homogeneous mixture, it would have to be exactly the same throughout.